Greetings, M Squared here. Today we are going to talk about exponential functions some more. Today we're going to focus on writing and graphing exponential functions. You should remember that this is the parent function, that b to the x power and a. So let's just go over really quick again so you make sure you understand what that is. A is the initial value, f of x is the function name, b is the constant ratio. All exponential functions have a constant ratio, something that's multiplied by one y value to get to the next consecutive y value. A can never be 0. If a was 0, 0 times this would be 0. It would no longer be exponential. B is our constant ratio. It has to be greater than 0, and it cannot equal 1. Why can't it equal 1? Because 1 to any power is 1, and 1 times a, it would just be a single number, which again would not be exponential. So you have to remember initial value, constant ratio. Today we're going to focus on the key features of an exponential graph. So look at these two graphs. We've looked at them before, but now you see a growth graph on the left, a decay graph on the right. We want to make sure we understand that a growth graph, when b is greater than 1, okay, that's what it says right here. When b is greater than 1, it goes up from left to right. When b is between 0 and 1, it goes down from left to right. We call that increasing as x increases and decreasing as x increases. You need to be able to look at a graph and know whether the constant ratio is going to be greater than 1 or between 0 and 1. That's super important. You need to look at it. If it's increasing, b is greater than 1. We need to talk about these key features. So first we're going to talk about an asymptote. An asymptote is a line that a function approaches, but it never really makes it to the function. It's always an equation of a line. You see, I said y equals some number. We don't know what the number is, but it'll correspond to our range. I'll explain a little bit more about asymptotes in a minute. We're going to move on to constant ratio. We've talked about the constant ratio. It's that b part. It's what you multiply the previous number by, the y value, to get to the next one. It's always going to be a rational number. It's going to sometimes be a fraction when it looks like this. That's between 0 and 1. And sometimes it'll be a number that's bigger than 1. Initial value is that a part. I'm going to be asking you all these questions. We're going to look at a graph. What's the initial value? Now, up until this point, we've just looked at the function and said, oh, the initial value is a. Now we're going to show you that the initial value on the graph is actually the y-intercept right here. For our purposes, that's what it'll be. The domain, remember, the domain is all possible values of x. You'll see that it goes left forever and right forever. Both of those do, so it's always going to be all real numbers. The range depends. Also, when we move into transformations, it'll change a little bit. But the range basically is going to be, if it's one of these two guys, it's going to be above that. Now, when you learn about flipping it over the x-axis, reflecting it, and all those sorts of things, that range will change a little bit. The domain's always going to be all real numbers. Increasing and decreasing, we talked about that a little bit. It's increasing as x gets bigger. It's decreasing as x gets bigger. Those always are in the condition of x getting bigger. So we're always moving from left to right on our graph. X and Y intercepts, you should know that. We've talked about that a long time, but I want you to understand there's a y-intercept, but there is not an x-intercept. Now, sometimes there can be if we shift them, but remember, we're not shifting them today, so there's not going to be an x-intercept today. The x-intercept is going to be a none. Then the next lesson is going to be about the transformations, and then sometimes we have one. So we're going to graph. We're going to need to know how to find all those key features. So first, we're going to graph using a chart, a t-table, right? T-chart. So we're going to plug -3 in for that x and find out what y value we get it. We're going to do all that. Then we're going to graph it. So real quick, I'm going to do this kind of quick. If you want to put it in your calculator, you can. 2 to the -3. Remember, negative exponent means to flip it over because they like to move it. 2 cubed is 8, so that's 1/8. If I put a -2 in, that's 2 to the -2. I'll show you what I'm doing there. That's 1/4, then 1/2. Anything to the 0 power is 1, and then to the first power, 2, 4, 8, 16. So there, I did that kind of fast, but you should be able to do that in your calculator. There are my y values. Is y increasing or decreasing? You can see it's increasing as x increases. I want you to notice, these are going up by 1. 1, 1, 1 everywhere. This is being multiplied by 2 each time. That's why we call it a constant ratio. What do you have to do to 1/8 to get to 1/4? You have to multiply by 2. What do you have to do to 1 to get to 2? Multiply by 2, multiply by 2. So our constant ratio is 2. That's how we can look at a function and see that. We can also look at a table and see that. So what is our constant ratio? It is 2. What is our initial value? Well, there wasn't one because I'm starting off pretty simple. So our initial value, when there isn't anything there, remember we just pretend, we don't pretend, but it's a 1. We don't need to write a 1 there. What's the domain? We talked about that for exponential functions, the ones we're doing. It's just going to be all real numbers. So I'm going to put ARN for all real numbers. Let's graph it and then we'll talk about the rest of these. So if I graph it, I'm going to go -3 1/8, -2 1/4, and 1/2, 1 and 2 and 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, way at the top. Okay, so here is my graph, right? It's going to hug this x-axis. It's going to hug it. It's never going to go beyond it because no matter if I put -100 in for x, it's still going to be 1 over 2 to the -2 to the 100th power. 1 over 2 to the 100th power. Now that's going to be a really small number, but it's not going to be 0. So that's where we get our asymptote. So where is our asymptote? It's this x-axis. What's the equation of the x-axis? Y equals 0. So what's the y-intercept? Right there. It crosses at 1. What's my x-intercept? Well, it never crosses the x-axis, so we say there aren't any. Range is y values. Remember, it goes left and right forever. Does it go up and down forever? Surely goes up forever. Doesn't go down forever. In fact, it never crosses this line. And if this line is 0, right, then it's going to have to be y is greater than 0. It's not going to be greater than or equal to 0. It's going to be greater than 0 because it's never going to cross that line. This might be one of those videos where you need to watch a couple times. Now we're going to graph one where b is between 0 and 1. It's a decreasing function or decay function. So still 1/2. Which is just the reciprocal of the 2 that we just did. So when we say 1/2 to the -3, we flip it over. That's what the negative does. Then we cube it. So I'm going to do that real quick. Again, you can do that in your calculator. That is 2 to the 1/2 squared is 1/4 and 1/8 and 1/16. Okay, so you'll see that those numbers are kind of similar. Just kind of reversed them. Let's graph that real quick. So at -3, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, and then we had a 2 and a 1 and a 1/2 and a 1/4 and a 1/8 and a 1/16, and it's just going to keep on hugging that line. So now I meant to show you this before. When x is 0, that's where the y-intercept is. So you can always tell what the initial value is on a table by looking for x equals 0. I'm going to say that again because that's super important. When you're looking at a table, you can tell what the initial value is by finding the y-intercept. It's right there. Notice there was never a 0 for x. And this is going to get smaller and smaller. That means there's no x-intercepts. The constant ratio is what I would multiply 8 by to get to 4. Now if you don't know what that is, you can go backwards and divide. But I know that I'd have to multiply by a half. Half of 8 is 4. Half of 4 is 2. Half of 2 is 1. So I know that my constant ratio is 1/2. Of course, you can always see it right there. But sometimes you're just going to have a table and you'll have to write the equation. Sometimes you'll have a graph and you'll have to write the equation. So we want to make sure you understand the backwards and forwards of that. The initial value, there wasn't anything here, so that means it's 1. We can also find it here, right? So our initial value is 1. The domain, again, is all real numbers because it goes left forever and right forever. The range is y is greater than, right? It's nothing down here. It's going up, whatever this line is, and that happens to be 0 in this one. What is the x-intercept? There aren't any. The y-intercept is 1. Let me make a prettier one. The asymptote is y equals, remember it's an equation, y equals 0. That's what this is the x-axis, but its equation is y equals 0 because everywhere on every point, right? This is 9, 0, -9, 0, -8, 0, -7, 0. All along that line, y is 0. That's why we call it y equals 0. Okay, now we're going to try one where the initial value has changed. The constant ratio is 3. That's what's inside our parentheses, or b. The initial value is 2. We know, because it's an exponential function, we already know that the domain is all real numbers. And we're going to talk about these in a minute. We probably should graph it first. So let's talk about graphing it. So I had graphed a lot of points before, but as soon as you kind of get the hang of it, you don't need to. So I always find f of 0. Well, what is f of 0? F of 0 makes this part 1, and 1 times 2 is 2. So when x is 0, y is 2. Now I'll find f of 1. Well, what is f of 1? We put a 1 here. So that's 2 times 3 to the first power, which is 6. 2, 4, 6. If I was to back up and do a negative, like f of negative 1, what would that look like? Well, it would be 2 times 3 to the negative 1, which would be 1/3. So that'd be 2/3. So when I come back over here to negative 1, I'm right here at 2/3. You can kind of see it, right? If I put a 2 in, that's 9 times 2, that's 18. That's off my grid. Not by much though, because I think I'm going up to 16 here, somewhere up there. And if I put a negative 2 in, that's going to be 2/9. So that's going to be just kind of smaller. So you'll see that when that initial value changed, how it made my graph rise quicker. But still, what's the range? This is still my asymptote, right? I didn't shift it up or down, so I still have that asymptote of y equals 0. I still have the range as y is greater than whatever that value is, right? Can't be that, it can be anything bigger. There are no x-intercepts, and the y-intercept is the initial value. Make that connection. You need to make that connection. The y-intercept happens when x is 0, and when x is 0, this becomes a 1, so you're left with that initial value times 1. So these two are connected. You want to make sure you know that. Because when you look at a graph and you have to graph it, you have to write the function from the graph, you'll want to know how to find that a value. And that is the graphing part. I think I'm going to make another video with the writing part, just so you don't kind of get overwhelmed all at once. Okay, M squared, signing out.